Hello everyone, welcome back for the next session on algebra sequence and series. I'm very excited to bring on the next topic. I think we have gone through a lot of different variety of questions so far, and sequence and series is another topic from which questions have always been asked. You can never say that there was no question of this topic, right? Always one or two questions are there, and very a mixed variety of questions are there, right? With different logics, and we'll be definitely having two sessions on this topic, right? And First thing that I want to say is that most of the people think that okay, if I know APGP, then I know sequence and series. Okay, if I know the formula for arithmetic progression, geometric progression, sum of n terms, nth term formula, infinite series formula, then I know sequence series. That is the first myth that I want to break. If you are having that thought, a sequence in general is any pattern of numbers, right? That pattern can have any mathematical formula or process behind that, right? For example, the most interesting sequence of numbers is the sequence of prime numbers, and there is no formula for the nth prime number, but it's nevertheless a sequence. So a sequence is just a pattern with or without a formula for the nth term, right? Definitely questions are there mostly on related to the nth term, what is a pattern, identification of pattern, and summation of n terms, summation of infinite terms, right? Finding the sum of first 10 terms. But the first thing is there should be a pattern. Without a pattern, there is no sequence. So let's see all the different uh, varieties around this. What kind of questions can be asked, have been asked, right? Again, I brought mixed of questions, both from my side, some original problems and some previous year questions too. Let's start the session. Here's the first one. The nth term of a sequence an is defined as, then the formula gets into two different explanations. Whether the number is odd or even, accordingly, the different formula is there. An is defined as n plus 1 over 2 if n is odd, or n by 2 if n is even. Then, theta question, you have to find the sum of the first 80 terms of the sequence. What you will do, right? Obviously, we'll just start putting the value of n. You'll just, because you have the formula, you'll just find what is a1, what is a2, what is a3. That's the only thing that you will do. Find the pattern in the sequence. All the concept of sequence and series is finding the pattern that exists. So if you are having the formula, just jump on to the given formula, just start putting n, the values of n, and just start finding what are the values of the terms, right? So let's do that. So what is a1? Put n as 1, and where you will put, on the first definition or the second one? Obviously the first one. 1 is odd, so a1 becomes 1 plus 1, 2 by 2, which is 1. Then a2, for that 2 is even, so come to this, 2 by 2, a2 is 1. A3, so 3 is odd, 3 plus 1, 4 by 2, 4 by 2, 2. A4, 4 by 2, 2. A5, 5 plus 1, 6 by 2, 3. A6, 6 by 2, 3. Now do you get the pattern? 1, 1, 2, 2, 3, 3. This is going to continue, isn't it? If you have any doubt, just find A7. It is again 7 plus 1 by 2. Yes, it is 4. A8 is obviously also 4. 8 by 2, 4, and so on. So the pattern is clear. It's a sequence of consecutive natural numbers repeating twice each. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So directly the question I have just written, the sequence is 1, 1, 2, 2, 3, 3, but then there is no logic in the question. There is nothing to do in the question if that was given. Okay, so indirectly, when we put the values of n, we get this pattern. We are identifying it. So that was the only thing to do. Now we have to find the sum of first 80 terms. So obviously till the 80th term, since we are repeating each number twice, we would have reached till 40, right? 1, 1, 2, 2, 2, and so on. 39, 39, 40, 40. So what is the sum of the 80 terms? This sum, 1 plus 1 plus 2 plus 2 plus 3 plus 3, up to 79, 79, 80, 80. So this is simply twice of the, sorry, my bad, not 79, 39, 39 and 40, 40, right? So obviously it is nothing but the twice of the sum of the first 40 consecutive natural numbers. And we all know that formula for that, right? So twice of 1 plus 2 plus 3 up to 40. So formula is n plus 1 by 2 for the sum of the first n natural numbers, right? 1 plus 2 plus 3 up to n is n into n plus 1 by 2. So twice of 40 into 41 by 2, 41 into 40, yes, 41 into 4, 164, so 1640, right? All right, so this was the first one. Next one. What is the infinite sum of the series given below? And now this time there is no formula. Directly the terms are written in a pattern. All the terms are fractions with 1 being the numerator, and each denominator is the sum of the first n consecutive natural numbers. So for example, in this sequence, the 10th term would be 1 upon 1 plus 2 plus 3 plus 4 plus 5 plus up to 10. That's the sequence, right? We have to find the infinite sum. Now, common sense tells us if we have to find the infinite sum, we have the options. We can always do little bit hidden trial, like from the options. That is one approach. From exam point of view, we can do that, which means to say, I know the terms are diminishing, means reducing, decreasing in value very rapidly, right? So the infinite sum should be very close to the sum of the first few terms only. So from the exam point of view, let me give that approach. Let's just manually add the first few terms. The first term is 1. The second term is 1 upon 3. The third term is 1 upon 1 plus 2 plus 3, 6. The fourth term is, this is 10. Then the next term will be up to 5. So another add 5, 1 upon 15. So let's say, okay, let's add this much. How much this comes to be approximately? This is 1 by 3, which is 0.33. This is 1 by 6, which is, I'm just adding all the decimals, which is 0.166. 1 by 10, which is 0.1. 1 by 15, which is 0.06. Okay, let's add one more term. Next one will be plus 6, which is 15 plus 6, 21. 1 by 21 is very near to 0.05. So roughly this is how much? This is 0.5. This is like, it's very decreasing very rapidly. So I don't think so it can go to such a huge value as 3 or 4. In my and infinite is obviously not the options because the terms are decreasing very rapidly. So looks like 2 must be the answer. From the exam perspective, we should mark that very easily. But what is the proper explanation, right? This is definitely the exam approach, but let's prove it why it is 2. So the thing is, the nth term, definitely we can write a formula over here. It is simply 1 over the sum of the first n natural numbers. It's 1 upon 1 plus 2 plus 3 up to n, right? That is the formula for the nth term, and this is nn plus 1 by 2. So this becomes 2 over n into n plus 1, right? This is the nth term. Now there is a manipulation that we can do with this. Take 2 outside, and can I say 1 over n into n plus 1? So I can write this as n into n plus 1, and I'm writing the 1 over here as n plus 1 minus 1. Try to understand what I'm trying to do. I'm splitting the term into 2 parts in a difference form. So it is becoming twice of n plus 1 upon this. So n plus 1 will cancel. So 1 upon n, and y minus, sorry, this is minus n. Sorry, not minus 1, minus n. Right? N plus 1 minus n is 1. And n cancels here. So 1 upon n plus 1. I can write 1 upon n into n plus 1, therefore, as 1 upon n minus 1 upon n plus 1. Now, I have to find the sum of infinite number of terms, right? Sum of infinite terms, S infinity. It is T1, T2, T3 up to infinity, right? So if I'll do this summation, then what will happen is, see, 2 is common. And so for the first term, I'll have 1 upon 1 minus 1 upon 2. This is the first term, twice of that. For the second term, put n as 2, you have 1 by 2 minus 1 by 3. For the third term, then you have 1 by 3 minus 1 by 4. For the fourth term, then you have 1 by 4 minus 1 by 5. So what is happening now? In each of the successive terms, the the successive terms are cancelling off. Minus 1 by 2 plus 1 by 2. This and this goes off. This and this cancels. This will also cancel off. Until infinity, everything will get cancelled off eventually. And all that is left is simply this 2 into 1, which is 2, which is exactly what we said should be the answer. Right. So therefore, this is kind of a special sequence. Always make note of this. This kind of pattern, if you get this kind of sequence, each term is expressed in the form of the denominator being the sum of consecutive natural numbers. So you can write the formula for the nth term in this way, right? 2 over n plus 1, and then remember this logic. This logic has been encountered many times in problems, right? If you have 1 over n plus 1, you can write it in this form, a difference, right? And then when you add the terms, everything gets cancelled off, right? So the answer is 2. Next one. How many terms of the sequence given below sum up to 1,000? And again, the terms are given very directly. And the pattern is also very evident. 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4, 5 minus 5, 6 minus 6, and so on. So the number and its negative value, they keep on appearing alternatively for all the successive natural numbers starting from 1. How many terms of this sequence will add up to 1,000? Means the question is asking for this sequence, if S of n equals 1,000, if the sum of the n terms of this sequence is 1,000, then what is the value of n? Okay, I'll give you 1 minute to think on this, right? This is, I think, very doable. Let me know if you can get this one. Yes, you can do this. Okay, let's discuss. Yes, I'm waiting on the chat box if anybody can give the answer. So, when it will become 1,000? So, it is very obvious, it is very clear. The first two terms will add up to 0. 1 and minus 1 will cancel off. If you add, however, the third term, till the third term, you'll get 2. But till the fourth term, the sum will be 0. Because 1 minus 1, 2 minus 2 cancels. So if you're adding the number of terms, which is even number of terms, your sum is 0. Sum of n is 0 if the number of terms is even. Sum of 2 terms, sum of 4 terms, sum of 6 terms, sum of 8 terms, and so on is 0, isn't it? But sum of an even number of terms is not 0. Sum till the third term is 2. Sum till the fifth term is 3. Sum till the seventh term is 4, and so on. So these numbers I need this number which appears to be 1,000. So 1 minus 1, 2 minus 2, and so on. Since I'm interested in the sum being equal to 1,000, so I should reach till 999. So 999 and minus 999. So till this summation, the sum of these number of terms is 0, right? And how many terms these are? Simply 2 into 999, because these are pairs of numbers, 999 pairs of numbers. So these are 1998 number of terms. And now the 1999th term is going to be 1,000. And then the sum of these 1999 terms is 1,000. So isn't that the answer? Till the 1999th term, the sum of the terms is exactly 1,000, because the 1999th term is 1,000, right? So it's all about pattern. I'm again saying that sequence and series is all about understanding the pattern given to you and working around that, right? Ready for the next one? Yes, let's see. Let's continue. Here we go. A sequence an has a1 equals 1, means the first term is 1 and its first n terms sum up to 1 by n for all n more than 1. First term is 1, sum of n terms, the formula is given. Formula is given, sum of n terms is 1 over n for all n greater than 1. Which term of this sequence amongst the following 4th, 5th, 6th, 10th has a terminating decimal value? Brilliant. So we need to identify the pattern in the terms. Need to identify the terms and then come to the 4th, 6th, 5th, 10th terms. Find which one has a terminating decimal value. Now, here is the logic I want to discuss. Very important. Whenever the formula gives the formula for the sum of the first n terms, which is happening in this case, this question tells me S of n is this formula 1 over n. The first thing that you can quickly jump on to do is you can find the formula for the ns term. Directly using this Sn, you can find Tn. How? The ns term, can I not define the ns term as the sum of n terms minus the sum of n minus 1 terms? Can't I say that? Isn't that what is the definition of sum of n terms? Sn is S1 plus S2 plus S3 up to Sn. And S of n minus 1, if you take away that, T1, T2, T3 up to Tn minus 1, you subtract. So all you're left with is Tn, the nth term. So you have Sn, you can find Tn in this question using this relation. This relation is always true for any sequence, whatever be the sequence, right? So Sn is 1 over n. So Tn in this case becomes how much? 1 over n minus 1 over n minus 1, isn't it? So this becomes n into n minus 1 is a LCM and n minus 1 minus n. So minus 1 is there in the numerator. So the terms are negative. Except the first term, which is 1, all the subsequent terms are negative in value. So T1 is given to be 1, or call that A1 as the question is saying, does not matter what name you give it. A1, the first term is 1. In this question, therefore, I have derived that An, the nth term, has the formula minus 1 over n into n minus 1, starting from 2n onwards, right? So what will be A2? Okay, I just need to find these terms. So what will be A4? So put in this formula, minus 1 over 4 into 312. Now this is not terminating. It is, we know this is 0.083333. This is not terminating, right? A5, the fifth term, will be minus 1 over 5 into 4, 20. Yes, this is terminating. This is the answer, right? 1 over 20 is 0.05. So minus 0.05 is the fifth term, and fifth term is terminating, right? 6 and 10 will not be terminating. Sixth term will be 1 upon 6 into 5, 1 upon 30 with minus sign, non-terminating. 10 term, 1 upon 90, 10 into 9, also non-terminating. So, right, make note of this. Tn, nth term, if you know the formula for the sum of n terms, how you can find Tn, right? All right, isn't it? Okay, now let's look at some previous year questions. Okay, now this came in CAT 2019. You can see the way the questions have been framed, right? Directly, the mathematical notations are there. A1, A2, A3. So clearly this notation is used and to depict, sequence. Whenever you see this kind of notation, A1, A2, A3, it means he's talking of a sequence. So now A1 plus A2 plus A3 up to plus AN is this 3 times 2 power n plus 1 minus 2 for all n greater than or equal to 1. Then you have to find the 11th term. I have just mentioned the concept behind this question just now. This expression is what? Nothing, but he has written Sn in the expanded form. He has written, okay, this is the sum of the first n terms of a sequence, and that is given as a formula over here. You have this formula 3 into 2 power n plus 1 minus 2. So simply plug in the expression and say that nth term will be Sn minus 1. You have to find A11. It's a theta question. So what is A11 going to be? Simply S11 minus S10. A11, the 11th term, will be simply the sum till the 11th term minus the sum till the 10th term. Put in the formula. What is going to be S11? 3 into, so put 11, 2 power 12 minus 2. That is S11 minus S10. So 3 into, right, 2 power 10 plus 1, 2 power 11 minus 2. When you subtract, then what you will be left with? 3 into this minus this. So minus 2 and minus 2 will cancel off. So we are left with 2 power 12 minus 2 power 11. 2 power 12 is as good as 2 into 2 power 11. So can I say this becomes simply 2 power 11 only? Why? Because 2 power 12 can be written as 2 into 2 power 11 minus 2 power 11. So this is 2 minus 1, 1 times of 2 power 11. So we are left with 3 into 2 power 11, which we need to write in the digit form. 2 power 10 is 1024. All of us should know that. So 1024 is 2 power 10. Twice of that, 2048. Thrice of 2048, 6144. That's the answer. Right? Sn is given. Any value of the term we can directly find. Right? Just numerically we had to compute the 11th term. So sum of the 11th till the 11th term minus sum till the 10th term is the 11th term. Isn't it? Okay, let's see next one. CAT 2021. Now this question is very interesting. It brings in the condition of positive integers. We have seen a lot of questions on integer constraint. Let's see what happens here. Three positive integers x, y, and z are in arithmetic progression. Okay, finally we have a question on AP. If y minus x is more than 2, what is y minus x? X, y, z are in AP. Y and x, they are consecutive terms. So y minus x, can I say, is basically simply the common difference of this sequence, right? So the common difference is more than 2. So it's an increasing AP of positive integers. And this equation is given over here. X, y, z is 5 times x plus y plus z. Then you have to find the value of z minus x from the options. Okay. Now, if x, y, z in AP, it simply means that the difference of consecutive terms is the same. That is the idea of AP, right? That the terms, right, have the same difference in the consecutive terms. So y minus x, the difference of the first two terms is the same as z minus y, the difference of the next two terms, or y plus y 2y is x plus z. So always remember, if x, y, z are in AP, then the middle term is the average of the other two. Y is x plus z by 2, or 2y is x plus z. This is the standard condition that you should always know. If three numbers are in AP, then the middle value is the average of the other two. Now come to this equation, and let's make use of this equation that we have got. X into y into z is given to be equal to 5 times of x plus y plus z. For x plus z, replace x plus z as twice of y. So this summation basically becomes 2y plus y 3y, isn't it? Right? X plus y plus z becomes equal to 3y. I can cancel now y on both the sides of this equation, right? And I'm getting that the product of x and z, the first and the third term, equals 5 into 3, 15. Now, x, y, z, and z are positive integers. X, y, z are positive integers. So the product of two positive integers is 15. There are not many different ways to express 15 as the product of two positive integers. Either we can do as 1 into 15. Remember, it should be an increasing AP. So x is always going to be less than z. or it can be 3 into 5, 15. There is no other third way to express 15. Now, the challenge is x, y, z are in AP. If I take them, the x and z to be 3 and 5, then it will become an AP of positive integers only. But the issue is that the value of y will be the average of 3 and 5, which is 4. And in that case, y minus x would be equal to 1, which will go against this constraint that y minus x needs to be more than 2. So this case will fail. It will not satisfy this constraint. So the only way we can have a solution is x is 1, z is 15. Then y becomes the average of 1 and 15, which is 8, 1, 8, 15. Right? 1 plus 7, 8, 8 plus 7, 15. This is what works. This is what works. So he's asking for the value of z minus x, which is 15 minus 1, and which is 14. Right? Isn't it? So just had to understand the mathematical conditions and just apply them. Right? Basic question, I would say, on AP. But with the positive integer constraint. All right. Let's see. Let's take the last problem for today's session. And this is one of the most interesting questions I have seen in recent years. CAT 23 had this question. Let both the series A1, A2, A3 and so on and B1, B2, B3 and so on be in arithmetic progression such that the common differences of both the series are prime numbers. Two APs, common differences are prime numbers. If A5 equals B9, A19 equals B19 and B2 equals 0, then what is A11? The mysterious thing on this question is that we don't see any numerical terms anywhere in the problem, and magically the question has some numerical answer and options are there, 86, 84 this. So how do we get that? Obviously this is the core idea, the core logic, that the common differences are prime numbers, and then we have these conditions. You have to make use of them and derive or figure out what could be the values of the terms. We have to find basically both terms. Now let's see what we can do. First of all, can I say that in any AP, let's say the terms are x1, x2, x3 and so on. If I'm saying that x1, x2, x3 up to and so on is an AP, can I say that the difference of the mth and nth terms, xm minus xn, do you agree this is m minus n times the common difference? Let's call that as d, right? We are adding the d consecutively to get the next term. First term is whatever the first term is, you add d, then add another d. So the difference of any two terms located at the mth and the nth positions. So from the nth to the mth term, you would have added d how many times? M minus n times. For example, the difference of the 10th and the 5th term of any AP should be 5 times the common difference. Agree with this? So we'll make use of this idea over here, because we have these two equations which can be used further to make use of this concept. I know that A19 equals B19. I also know that A5 equals B9. If I subtract these two equations, then I will have this kind of expression. A19 minus A5 equals B19 minus B9. Right? Now, let's call D1 or A1, A2. Yeah, D1 and D2. Let the common differences of the first and the second sequence be D1 and D2. So A19 minus A5 will be 14 times the common difference D1. 19 minus 5 is 14. And over here 19 minus 9, 10. So this equals 10 times the common difference D2. D1 and D2 are prime numbers, and we are having this equation. 7D1 equals 5D2. D1 and D2 are prime numbers, and D1 and D2 are coming to be in the ratio of 5:7. They are prime numbers. They can only take this value. Right? In general, D1 is like 5k and D2 is like 7k. K can only be 1. If you take any other value of k except 1, D1 and D2 will no longer be prime numbers. So we conclude that D1 must be 5, D2 must be 7. This is our conclusion. Now we have to find A11. So A11 is basically the first term A1 plus 10 times the common difference D1. So we have to reach till the value of the 11th term. We need to find the first term. How do we find that? That is a challenge. We have not yet made use of the result given to us over here that B2 is 0. Obviously, we have to make use of that. Okay. Now, if B2 is 0, it basically tells me that since I found D2, right, I'm trying to find A11. Let me do one thing. If I know B2 is 0, from B2, I can reach to, let's say, B9. And B9 equals A5. And from A5, I can reach to A11. Given that I know the common differences, I can do that now. So what I'll say, okay, I know that B2 is 0. If B2 is 0, it means that the ninth term, B9. So from the second to the ninth term, I'll be adding 7 times the common difference, right? So B9 will be B2 plus 7 times the common difference D2, right? B2 is 0 and 7 D2 will be 7 into 7, 49. So the ninth term of the second sequence is 49 and B9 equals A5. So then A5 is, if A5 is 49, so it means that I'm trying to find my 11th term. So that is 6 common differences ahead from the 5th term to the 11th term, right? So A11 will be A5 plus 6 times the common difference. So 49 plus 6 into 5, 30. So 49 plus 30 is 79, right? That's the answer. So magic does happen, right? Just a word problem with 2 sequences given, some equations given, prime number constraint, and you create the numbers. The core idea was to get to this kind of a result, right, from these equations, and then you derive the value of the common differences. All right, so this was the first meeting. As I said, we'll be meeting again on this, but I have put the basic idea in with you that sequence series is all about identification of pattern. And I've also shown you how in the recent year questions have been asked, and we'll continue this with more variety and other varieties of problems in the next session. So I hope to see you very soon. Stay in touch. Let me know anything that you want to share with me, any comments, suggestions. I'm looking forward to that. And a big announcement, Race to 99 percentile, a very big event is coming up very soon. So put in your calendars, August 2nd and 3rd. All our big mentors will be there for the 2-day event, Race to 99. This is the entire schedule. So lot to drive from here. So stay in touch and mark your calendars for Days to 99, not to be missed. Thank you. Thank you so much. And I'll see you very soon. Thank you all.